Hi there, this is Perry again. Welcome to my workbench. This is my, what I want to call uglier than sin workbench. And today I'm going to share with you something that I haven't shared on the channel before, and that is my interest in old computers. And old computers is sort of I guess dating me, because the one I'm going to be building today I actually bought brand new, and that was in 1993. So what we have right here, this is an AMD 386 DX40 with a math coprocessor. So I don't know really how to present this information in any way that isn't content dense, but to give you some idea, so this is one of the, this is the final release of the 386 in any revision. And back in the 90s there was a fight between Intel and AMD about who had the right to produce chips and whatnot, and AMD won the right to produce the 386 DX40, and this chip, for all intents and purposes, is identical to Intel chips, and they were using Intel's masking, etc. Now, this coprocessor right here, this is a math coprocessor. Back before the 486 days, computers didn't come with a floating point unit or a numeric processor unit or coprocessor. And in order to do things like AutoCAD and whatnot, which was the most common business use, they had a coprocessor. And there were really a couple different variations. This one is a Cyrix FastMath. As you can see, there's more pins. There's also another one called a WeTech coprocessor that was available. But this one is, for all intents and purposes, Intel compatible. I presume it's slightly better design and it's faster in certain ways or another. I don't really know. So this allows it to process floating point calculations in hardware instead of emulating it, which is a lot slower. This motherboard I bought in November 1993. I believe it cost me between $90 and $100, and this was the first computer I actually bought. Previous computers I purchased, I didn't really buy them retail. My previous computer to this was a 386 SX, and that was a motherboard that came from Weird Stuff. It was in the $2 as-is bin, and I built up a computer out of that. So this was the first one I actually bought. And as you can see, it's a rather small form factor. This is what they call the AT form factor, which really is delineated mostly by just the hole placement and the spacing of the slots and whatnot. As you can see, this one has 5 slots, and because of that, it is a little bit limited. The standard for AT motherboards was 8 slots. So this is a cost-reduced version of a motherboard, which is reflected in the price I paid. It has 8 megabytes of memory. Now I said megabytes, and to give some of you that are not familiar some context, there are 1,024 megabytes in 1 gigabyte. My computer over there has 32 gigabytes of RAM in it. So I really don't have the time to do the math on the moment or on the fly, but suffice it to say, this isn't very much memory. The card that I'm recording this on, I'm recording at 24 megabits per second, and you divide that by 8, that's 3, so that's 3 megabytes per second of video that I'm recording, and this is 8 megabytes. You could store just over 2.5 seconds, or just about 2.5 seconds of video in all of the memory of this. That's how little memory this has in it. And 8 megabytes is very functional for an old computer. So the objective that I have here today at my workbench is I'm going to rebuild my not my first, but one of my original PCs. And this is the motherboard. It says warranty void if removed. It's got a 9 circled, and this was bought in 1993 and manufactured in 93. So this motherboard, let's see, it was 25 years ago. Yeah, 25 years ago this month I bought this. So that's going to be the base. And when I say base, something that's very different about AT motherboards from current motherboards is that you don't see any connectors except for a keyboard on this. And that's because computers didn't have anything built in back then. You got a central processing unit, a coprocessor, memory, a keyboard, and a bunch of slots. And it's a double-edged sword not having anything built in. The downside is you have to supply all the cards to make this work. So what I have here, this was not in the original computer. Originally I had, so the original drive I had was a 40 megabyte MFM. It was a Rodine drive. The second drive I had was a 152 megabyte SD drive, ESDI. And then I got on this kick to want to try OS2 at one point, and it doesn't support SD or the old MFM, so I had a SCSI drive in this, and I'll bring that out and show it to you later, or maybe another video. But this originally had an Adaptec 1542A 16-bit SCSI controller, and the hard drive that was connected to it was a 345 megabyte Maxtor, which I still have. So this right here is what you would call a multi-IO card or a super IO card. What it contains is some of the essentials, and when this was built, these were just kind of coming into vogue because the IDE adapter, or ATA, was relatively new at that point in time. And what this does is it wraps up a bunch of functions. You get a printer port, you get a game port, you get a floppy drive controller, you get 2 9-pin RS-232 serial ports, and you get an IDE disk controller, all in one card. So if you had to put all this together, like let's say you had a MFM controller, that's just floppy and hard drive, and then you had to put in a serial port, so that would get you 2 serial ports, and then you had to put in a parallel port, which usually got for free on video cards. So this basically gives you 5 things in one, and they usually retailed for about 20 bucks back then. Good luck trying to find one for 20 bucks today. So this is the disk controller, the floppy drive controller, serial ports, parallel port, and game controller. The next thing that we have, this is the original. This is an NE2000. That's Novell. I think it was Novell Ethernet or Novell Eagle. Anyway, this is the gold standard for network cards back in the day. If there was, if there was sort of the, the generic equivalent of, like, say, the SD card. Everything takes an SD card. Well, everything supported the NE2000, and this one was a later variant. It contains a 10 base T port, AUI, and 10 base 2 or ThinNet port. So you could connect this to any network that you would find, and this is not very fast. 10 megabits per second is roughly equivalent to 1.2 megabytes a second. Now, going back to this video, I'm recording at about 3 megabytes a second, and 10 megabits, to give you an idea, is, let's see, you would be able to watch a high-def movie over 10 megabits, but you wouldn't be able to watch a 4K or Ultra HD movie. So 10 megabits is pretty slow by today's standards. So to sort of put a cherry on top of this build, I'm building a dual monitor computer. Now, I've got 3 monitors on that computer, 1 on that one, and having multiple monitors today is really kind of passé. It's boring. But back then, it was the whiz-bang stuff. And so we're building a vintage computer circa 1993 with dual monitors. And I've got some cool demos I'll show you about dual monitor support. If you go on YouTube, you'll find people talking about dual monitors, but they really don't have the software to demonstrate it. And I just happen to have all the software to demonstrate it. And there's one really cool one I'll show you that I didn't expect. So to do the dual monitor, to give you some context, I won't try to go real deep into this, but we need two displays. And in today's computers, you can put multiple display cards in the computer, and it'll just smartly figure out, I've got display card A, B, and C, and hey, you've got monitors connected to A, B, and C, and do you want to extend your desktop to the monitors? You know, it's trivial. Back then, the technology was in its infancy, and it was arguably a lot simpler. And to do dual monitors, one of them had to be a monochrome monitor. And if you've ever been to, like, say, who is it? A lot of insurance places used to have terminals, and even today they have terminal emulators because the insurance industry seems stuck on 80s technology, and so they've got mini computers with terminal emulators. But the video stores, they used to have the little barcode reader and a Weiss terminal, and today you really don't see a monochrome CRT anywhere. The closest that you get is an old ATM that doesn't have the new color screens. Old ATMs, monochrome CRT. So to drive a monochrome CRT, you either need an MDA, which is a monochrome display adapter, or a Hercules graphics card. And I happen to have an original Hercules graphics card. I replaced the two capacitors, the electrolytics that were on here, and it works just fine. So a Hercules graphics card, to kind of give you some background context, it is backwards compatible with the monochrome display adapter, but it has considerably more memory. This has 64 kilobytes of memory. Again, kilobytes is pretty small, but the Commodore 64 had 64K of memory for the entire system. This has 64K just for displaying graphics. And with 64K, you can display two graphics pages, which means you can be showing one page while drawing to another one. Because computers were kind of slow back then, you would get the ability to write to one and then display the other, and then you could flip-flop back and forth. So this has 2 pages of video memory. It has a parallel port, which is standard. The MDA had a parallel port, because back then you didn't get the information out of the computer except through printers. Hardly anybody used a modem, and it was for consuming. It wasn't really for sending. So this is a Hercules graphics controller, and I've got right here, I've got an old green CRT monitor, my original one from many years ago. Now, no computer would be complete without noise, and that's the sound card. Today we take it for granted that every single computer has the ability to put out audio. You've got a little jack on the side to plug your headphones into it, even your cell phone, same difference. So what we have here is a MediaVision Jazz 16. It's a Sound Blaster 16 compatible sound card. It has a game port, so I've got 2 game ports in here, which could be a problem if I hook a joystick up to it. It has an output with an onboard amplifier and a volume adjustment here. And this particular one, it actually has a SCSI controller. So Small Computer System Interface is what SCSI stands for, SCSI. Back in the 80s, 90s, it was somewhat common for CD-ROM drives to be a SCSI interface, which in the computer that we're building, I do have a SCSI CD-ROM in there. So we may actually end up using this to talk to the CD-ROM drive if I can find drivers for this future domain SCSI chip. So this is the sound card. It was pretty whiz-bang for its day. 16-bit synthesis was pretty much the top of the line. This is the primary video card. This is a VGA card. It's got a 15-pin D-sub connector on it, and it's a rather unusual form factor, because this is a Video 7. They were a company, let's see, they went out of business probably early 90s or so, but Video 7 was sort of on the forefront. And this is a Video 7 fast write VGA. And what makes this card, sort of odd in its form factor is that they copied IBM in the form factor. So these pin headers are IBM compatible, and this was introduced by IBM. This is the feature connector. I don't know that there was ever any boards that went on this, but the key features of this video card is that it has 512 kilobytes of RAM, so half a megabyte, and with 512K you could display 640 by 480, 256 colors at a time. And that's really it. Compared to today, where you take for granted that every single device, your cell phone, your computer, it's all true color. It's all 16.7 million, and now you've got HDR, which is 10-bit color, so 30 bits, over 3 channels. This is old, and the reason why it's called a fast write VGA is that in this big chip right here, they have improved the memory access capabilities so that the card itself can be displaying video while the computer is actually writing to the video memory. Now, they made 2 versions of this card. They had one that was the fast write, and then they had the other one was called the VRAM VGA. And the chips, everything was the same except for the memory right here. And the VRAM VGA used dual-ported video RAM. And what that means is that you can simultaneously address and write data to the memory while the video card is actually reading data from that memory, because there's 2 ports. There's a read-only port and there's a read-write port. And what that does is it frees up the CPU of the computer to do other things much quicker, because the CPU has to wait for this memory to be written, and if the video card is reading from the memory while the CPU is waiting to write, it has to sit there and wait. So those are called wait states. What the fast write VGA does is this chip right here becomes an arbitrator to memory access, and it allows the CPU to get on with its job much quicker without resorting to VRAM or video RAM. So this is just normal, DRAM. There's 8, so these are 1 bit by 256 kilobit RAM chips instead of 4 kilobit, which was much more common. So anyway, this was a pretty whiz-bang video card. This is my first color video card. I kept it out of for nostalgic reasons, and that's what we're going to be building this computer with today. So I think I'm going to stop there, because this is getting a little bit dense and is getting a little bit long. So we'll stop there, and then I will show you the case in the next video, the case that I'm going to use to build it, and we'll actually get down to the nuts and bolts of assembling the computer. So thank you for watching, and have a nice day.